Hi, my name is Cody. I'm a software engineer here in San Francisco. In this video series, we are recreating Lovable from scratch using LangGraph. In the last video, we refactored our project to entirely rely on LangGraph so we can run it with LangGraph Studio. And we're going to start pushing on our agent a little bit more, trying to make it a lot more advanced, make it a lot better. There's still some issues when you're generating the code where you need to debug it and the agent isn't always perfect. But before doing that, we're actually going to take a step back and we're just going to try to clean up some of the current code that we have. Specifically, what we want to do is with the latest changes that we made, if we were to come in and ask to change something, for example, please change this background color to dark instead of white, then right now the agent doesn't even respond. There's a couple things. Right now, as we've added more prompts and we've chained more things together, the response time takes a minute. And right here, you can see it's just spinning. It takes a long time. And then with our current implementation, we actually broke something where the agent doesn't even, it responds with a message, but since we're now using LangGraph, our response in our app.py doesn't return anything that's very useful for the front end. So it actually is a little bit of a regression. And what it does is it actually puts this little empty message that gets sent back. So obviously, we should fix that. But the other thing too is we actually want to implement a little bit of a better user experience where we stream back results directly from the agent. And this is one of the benefits of using LangGraph is it has built-in streaming where as the agent kind of goes through its thinking, as it goes step by step, as it kind of traverses, at first it will go to route initial user message, then it will go to design and plan, then it will go to write HTML code. One of the cool things with LangGraph is that we can actually just with a very, very simple change of one line of code, change it so that it starts to stream back messages from the actual graph as it's running. And this becomes a very powerful user experience. And it's just one of those things that all of the agent tools and large language models that are being built on, it really kind of requires this because it does take quite a while sometimes for the large language model to fully respond to the user. So just keeping the user up to date as the process is playing out and having it stream back real-time events through a WebSocket is a huge unlock from a user experience point of view. Otherwise, you get the experience that we have right now where you're just sitting there and waiting, and then 30 seconds later, 45 seconds later, you finally get the response. So that's what we're going to do in this video. We are going to try to aggressively use Cursor to just vibe code this as much as we can. That's one of the fun things about this new kind of era that we're living in and having tools like Cursor and these large language models. What's the point of having these great language models and tools like Cursor if we don't really try to push them to their limits? So I'm going to try to move very aggressive and very fast because ultimately this series is about implementing LangGraph and more of the agentic stuff, whereas this WebSocket stuff's a little bit just more boilerplate kind of coding. So let's just jump right in and get aggressive. So jumping into our app.py, the first thing that we can actually look at is we have this document about streaming from the LangGraph team, and it's basically just the docs that tell you. So it's as simple as going for mode chunk in graph.stream inputs, and you give it the stream mode, print chunk. So it's a very, very simple interface. So right now we're actually just doing output equals graph.invoke, but with a very, very simple couple of changes, we can get this streaming back in real time. So let's go ahead and do that. So what we're going to do is we're going to change this output to actually be stream equals. Then we're going to change invoke to stream. And then in here, we're going to add a new variable, and we're going to say stream mode equal values, but then we actually want it to be a list because there's multiple streaming modes in LangGraph. So we're actually going to have it just stream everything at first. Okay. And then the other thing is Fast API actually does have a streaming response object that we can use to stream stuff back to the client as we, so it's basically just a wrapper for a WebSocket object that will stream stuff back to the client in real time. Now the syntax here is a little bit interesting. What we're going to do is inside of our async method for chat message, we actually need to define a new function that's basically going to wrap all of this into a kind of response generator that as the LangGraph object is streaming back responses, we're going to have it in this function, and then in this chat message we'll actually yield to that function. It's a little bit interesting, just bear with me. So what we're going to do is using async def response generator. Okay, that's what we're going to call it. Let's wrap everything in a try except print starting. Okay, we'll go ahead and log it if there's an error. Okay, let's move our graph logic up here to our new method. Awesome. Now we got our stream here. And then we also want to make sure that we say, please use fast API stream in response. Okay, let's go ahead and send that in. Okay, that's just thinking now. Let's go ahead and let this generate, and then we will apply it manually. Okay, it's coding it up for us. Okay, so it did our implementation here. Let's go ahead and apply it. Okay. Next, let's go ahead and implement the same thing on the chat side. So what we're going to do is we're going to need to tell it to implement this. Please, okay, given this, now please update chat.html so that it can receive the streaming messages in a nice, simple, and elegant design so the user can see the messages as they come in. Okay, let's go ahead and send this off. Let's just see what it comes up with. Okay, that's cooking up. I'll go ahead and pause it and finish when it's done. Okay, that's finished. Let's go ahead and hit apply. Let's just kind of see what it comes up with. We're kind of being a cowboy coder here, right? With some AI, some gunslinging. All right, let's try it out. Let's come back over here. Okay, please change the not bad at all. Processing updates, processing messages. I mean, something like this, right? This is such a better experience because you see that it's changing, it's iterating through the values, and then it gives us this little drop down. I don't know if it's streaming too much. So it's, oh, there, I mean, yeah, it's showing some information that's streaming through. Okay, let's see. So now we also need to wrap our head around the kind of format of this data a little bit. Looks like there's 3 fields. There's values, messages, and updates. This should map approximately to what we are responding to with our LangGraph string. Yeah, right here, values, updates, messages. So this maps exactly into what the LangGraph is actually responding to. But I mean, it's just pretty like cool how quickly we can start streaming stuff back to the user interface. Where if we weren't doing this, there would just be so much more plumbing that we'd have to wire up. But LangGraph just takes care of a lot of that out of the box. So that's one of the benefits. A big benefit of using LangGraph is they just have this streaming that's already set up. And then you combine that with something like Cursor and some, AI vibe coding, just kind of pushing on it. Like, it's pretty crazy how fast you can build some of these things. Okay, streaming did end. Oh, cool. Okay, so it did finish. That iframe refresh did work. Oh, cool. And then it does say, I've processed your request complete. So this already is so much better than it was. There's still a little bit more, though, that I want to push on. One is I want to like push a little bit and try to separate out these values, messages, and updates to be something that's even more user-friendly. So looking a little bit closer, the one that probably seems the most relevant to us is actually the LLM token output. So that's coming from this messages stream. So if we go back to our code here, so in fact, what we're going to do is let's just tell Cursor, please dump the information out as it's streaming, so we can copy the logs out of the console and put it and paste it and send it to you, so that we can have better understand the structure of the data, so we can make a better user. Because right now it's. I don't know if you would call this a hallucination, but it's just like it doesn't know exactly what the data shape looks like, so it's kind of guessing a little bit. It's trying to intuit it. So what we're going to do, we're just going to actually put some logging in the browser side of things, and we'll just dump the information to the console, and then that will kind of tell us the shape of the data, and then we'll give that to Cursor, and we'll tell it based off the shape of this information and data, let's go ahead and update to improve the user experience. So kind of a hacky way of doing this. There's multiple ways to crack this. For me, I'm just very I like to just lean very heavily on the large language models. A little bit of a funner experience, right? They can speed you up, but you also gotta be mindful too that you want to learn this stuff in depth. And so sometimes I'll try an experimental approach like this, and then if I get hung up on issues, then I'll be all right. Now I have to go read the documentation, actually think through it, and debug it a lot closer. Okay, so we implemented that. Let's go ahead and let's just try this and see what happens. Please change this to be a Pomodoro app as well. All right. Okay, added some kind of cool debugging. Update event, stream event, stream event. Yeah, I mean, it's dumping a lot of information in here. Value, AI message chunk. I think too that these are strings. That's another problem, is we almost need to JSON parse these in real time from the browser. On the browser, actually parse them. Oh, in fact, it looks like, we'll actually parse the value. Value node message. Yeah, I mean, it's dumping a lot of information out. So in the meantime, let's just grab some of this information. Let's just throw it into Cursor and see if it does that. I'm gonna say, here's the shape of the data based on the logs. Please update the user interface to make this a better experience for the user. I mean, we're throwing a lot of data at Cursor. I mean, it's Claude 3.7. Let's just see what it does. Let's see, removed it. Say, can you please add a game, or can you please add rainbow toggle mode on this page as well? All right, moment of truth. I do like this AI is typing. I don't like that this is formatted in a JSON object. That's kind of not very user-friendly. We also lost our writing label right there. Okay, so it is streaming back, but it's just not quite doing this quite right. So this is going to require a little bit more of thoughtful thinking and debugging and all that kind of stuff. Okay, I have to dive a little bit deeper. It's not doing quite what we want. So sometimes you try to vibe code and it just doesn't work. So you gotta actually read the documentation and think about some things. So go ahead and pause this, spend a little time thinking about it, and I'll come back with whatever I find out. Okay, so one thing I did is I put a breakpoint, and then I put a breakpoint in each stream instance. So basically I found what the large language model did was it's iterating over them, and then it's checking the different types of this instance that's coming back. And it's a dict or a tuple otherwise, and then it basically, so what I did is I put a breakpoint each three, and we can because what's happening is it's streaming from all three of these, and there's no type checking or pedantic kind of model validation. I mean, this is the type checking, it's checking the instance type. But anyways, we're on line 111, which is a tuple, it looks like. We can even ask, is instance chunk tuple? That's true. And then, so in this case, this is, we look at its actual updates. So this is the updates. Updates streaming from LangGraph. That's the specific type. It's a continue. Oh shoot, if you save it mid breakpoint, it can break fast API. Okay, maybe not. 111, 111, 111. Oh, see, but that's confusing because now it says messages, right? So 111 could be messages or it could be updates. Okay, so I got a breakpoint here, and basically what I did was I changed it to only stream back messages, the stream mode only messages. And then what we do is we have this chunk. And the first, so it's funny, it's like a tuple of a tuple, right? So you go type chunk, and it's a tuple, right? Let's go type chunk 0, I think it's just a string. Yeah, so chunk 0 just says messages, right? So chunk is actually messages, and then you have the second chunk. So the second object, the first one is this AI message, oh sorry, this first one is this AI message chunk, which is a LangChain primitive. But then we also have this second one, which has the actual LangGraph state, which is a dictionary. And then here you could actually go LangGraph node, and that would give you the route initial user message. So the LLM wasn't really able to figure this out. Sometimes you have to have like a breakpoint and actually look at this stuff. But what I usually do, so what I'm going to do in this case is if it comes through this, if this is a chunk tuple, then we know for a fact this is a messages chunk. This is a messages chunk. So I'm just going to document this. And what we're going to do, in fact, the other thing we're going to do is we're going to say, is this chunk a message stream type equals, and we're going to do is instance and length of chunk equals 2. Okay, and then rather than having this whole nasty thing, we'll just say else if is this chunk a message stream type, which is just a boolean. Okay, if it is, then we can say, we're actually going to say chunk 1 1. We're going to say LangGraph node info equals chunk 1 1. Then we'll say AI, or we'll say message from LLM equals chunk 1 0. And this is an AI message chunk object. And this is just a dict object. What were the keys in here again? Can we just call keys? Yeah, here we go. Yeah, so then it has these keys in here. So I'll just document this. Yeah, with dictionary keys, LangGraph step, LangGraph node, LangGraph triggers, LangGraph path. So it has some kind of meta information about the, so you could go, for example, LangGraph node right here, and this will tell us the route initial user message. So that's very helpful information. And then from there we can yield it back. Now I think that, let's just double check this though. I mean, the other thing to check is this actual chunk 1, in fact chunk 0. That's actually the string type. So I do wonder if this has the same shape for updates. To test that, let's just go ahead and, oh man, there's going to be a lot of breakpoints in here. Let's just kill this. Exit. Sometimes this happens. Did I kill it? Oh yeah, it already killed it. Perfect. Okay, I'm going to stream this back with updates now. And we might actually hit that same breakpoint. Turn this into a game of chess. Oh yeah, we do. Yeah. Because it's a, so yeah, we gotta be careful here, because this actually isn't. So it should be, if is instance this, I mean, because if we were to go chunk 0 here, whoops. Yeah, updates. So we say and chunk 0 equals messages. Because I don't think, if we go chunk 1, yeah, then the second object is just a dictionary. Route initial user message. I think I'm guessing that this is sending back the state object. In fact, I kind of just want to inspect it. Is this chunk an update stream equals is instance this and chunk at 0 equals updates. So we'll just do else if, elif, yeah. I mean, basically just doing the same thing, except the variable names will be different. Like in this case, this is a think this is actually the LangGraph state object equals chunk1. And this is a dict object. And if it's just a chunk, oh, if it's a dictionary, I think that's probably this values thing. Let's go and just test this though. Oh no, it's not happy. Why is it not happy? Let's look. Invalid syntax, okay. Oh, these ands. Oh. Python world. Gotta remember that. Okay. Turn this game into chess. Ah, did not like that. Oh, right, because it's not a dict in the first one. It's not a tuple of a tuple, so this one's gonna actually be chunk1. That's what that is. Alright, moment of truth. Alright, does not like node. Flipper, dude. Why do you not like this? Oh, we gotta add this right here. That's what's going on here. Oh, node value. Okay, so if it's a tuple, I see. Basically, it's calling it node and value, which is a dangerous assumption, but okay. Oh, it's saying route. Okay, here we go. Alright, so we're not hitting my breakpoint. Okay. LangGraph state object, node value equals chunk. LangGraph state object, okay. Right, so now it's going into the next step here. So I think what this does is it's like, this would be like routing. So that's the node. And then this is the state. So this update returns essentially the state object. Design and plan, design and plan. Okay, so it's returning the So update is returning just the I mean, that makes sense. Just the updates to the state graph. And it's actually returning the state. So basically it's returning design, and it's basically returning this right here, the new state, the design plan, and then the design plan. And it's keyed by the design and plan being the node name that's defined in nodes.py. Yeah, design and plan is the actual string that points to the function. So We have this. So for write, okay, so based on that, we could actually listen in the HTML code. That's like, and to get the actual step would be a little bit interesting, because let's see where we at on this. Right, so then this is the actual response. So, I mean, what's chunk? Chunk 0 is updates, okay. Chunk 1 dot keys. Okay, so then the actual node name, we just found out. If we get into this point, then we can say node step name equals this list chunk. These objects are just pretty ugly. Which I'm sure we could get all this from just reading the documentation, but I love just getting a breakpoint in there and just inspecting the object at runtime. That's how I like to develop. To me, it's just a little bit quicker. So we go node step name. So this will be either write HTML code, will be one of the following options. Yeah, design and plan, HTML code, route, initial user message, respond naturally. So these are the different updates. Okay, so that makes sense for updates and for, so the actual state change then. Updated state object equals chunk 1. Hang on, we're on the wrong branch here. Updated, oh yeah, LangGraph state object. I'm gonna say updated LangGraph state object. Okay. Is this chunk an update stream type? Okay. Update a LangGraph state object, node step name will be one of the following, right? And then based on this, you could actually look and like see what the updated state is. And then so for example, in here, you could say if this is a respond naturally, route initial user, etc., then we would know the key update to the state. Because we have messages, so we have initial user message, existing HTML content, design plan. Okay, it's making more sense. So for values, for streaming values, it will actually return the entire state object right here. Like, so that'll include basically the entire, and that's pretty heavy. I don't think we actually need all of that. It'll include all the messages, initial user message, existing HTML content, final HTML content, and then the design plan. I think in the future that actually could be helpful, especially if you were doing existing HTML content and final HTML content. That could actually be very, very useful because we could do like a real-time diff, maybe even in the iframe or like a code diff or even just a visual diff. So that I do think that could be helpful in the future. So that is good to know. But I think for now, probably the only two that we need is just these updates and messages. So let's just change this to updates, messages. And as far as values, I'm actually going to close this. and then say values is the third option to return the entire state object. Okay, and then in this case, it never actually hits this is instance chunk dict, so we're going to delete that entirely, which means we can just make this an if, an else if, and then else. We'll just keep this how it is for now. Final state equals chunk. I think we can, let's see, I think we can get rid of this too. Okay. Okay, a couple more cleanup steps. This final state is a little bit old. I'm just gonna get rid of a bunch of this, honestly, because we already yield back the JSON. This is just kind of noise, in my opinion. Okay, we catch an exception. We send an error if it doesn't. Okay, so just to go over this really quick, this is a little bit more simplified, and we just have these kind of Boolean variables that just kind of helps the logic read a little bit better. So is this chunk a message stream type? You know, basically just saying that that's coming back from LangGraph streaming as a messages stream mode. I actually want to change this variable name a little bit more too, just trying to like make this really clear and understandable. I'm going to say, is this chunk an LLM message stream type? And the reason why, in fact, let's even call it, is this chunk an LLM message? Okay, and this I think just provides a lot of clarity when you're thinking about variable names, because now we can go through and read this code a little bit, you know, almost like pseudocode. If is this chunk an LLM message? So if this is a message from the LLM, right? If this is a message from the LLM, known as a messages chunk streaming from LangGraph. Okay, then get the LangGraph node info. This is a dict object with keys, LangGraph step, LangGraph node, LangGraph triggers, etc. So then in here we can actually case on LangGraph node if we wanted to, and then we can also say get the AI message from the LLM, and this is an AI message chunk object. In fact, let's even grab the LangGraph AI, or I think it's a LangChain primitive. Yeah, it's this one right here. Yeah, this AI message chunk. So I'll even put this link in the source code just to make it really easy. AI message chunk object. Okay, so message from LLM. Node value. And then as far as node, we can even say LangGraph node info, LangGraph node. And then as far as this value, instead of calling it value, let's just call this message from LLM. And as far as us dumping back node, let's change this to be LangGraph node info, and let's change this to be message from LLM string type. And I think even this will change how we can start to piece together the information in real time back on the client side of things. Okay, and then here, let's do the same thing. Let's change this to node step name. As far as value, let's just change this to an updated LangGraph state object as the value, and this will yield back. And so this will work with our existing client code, just because right now it cases, or it indexes into, it gets the key node and gets the key value from the streaming objects. So let's go ahead and try that. Let's restart our server just for good measure. Let's jump back into our Python interface. Let's change this to say, please make this a to-do list app. Let's just see if anything changes. So this already is better. Route initial user message. Okay, now it's streaming information back under this design and plan concept. And it says, look, processing design and plan. So this is already a lot clearer what it's doing. Okay, now it's doing write HTML code. The only thing I wish is that maybe the stream kind of concatenated on top of each other rather than it needing to rather than it like just like cycling through. Okay, and then it also doesn't process like an end request, and it doesn't refresh the page. So let's refresh it ourselves. Yeah, so this is working. Okay. Boom, boom, boom. Okay, very simple. So let's go ahead and save our progress here. Let's jump into our chat.html. And then now what we want to do, let's go to where we're appending all of this stuff here. So we have like node. Okay, so node content. I'm gonna go ahead and just take this entire block of code that's processing this, put it into cursor and say, please change this so it appends the outputs rather than simply replacing the content of the value from the node update. Let's see if it knows what I'm talking about. Data.type equals update messages. This might be right. I don't know if this is right. It depends what this type is and what this data is. Data.type. Data equals JSON. I mean, I don't know if this is right. This seems a little bit like hallucinated or just a little bit made up, because I don't think we actually have a type in this. Oh no, we do. We have a type right here. Okay, so it's casing on this type. If type equals start, if type equals update. So this would be LLM message. If type equals, oh, so they don't even have. Okay, so this. There's a little bit of flexibility here that we might need to adjust. Type equals end. Okay, let's just see what it does. Power of cursor. All right. Cool. Let's refresh. Please turn this to dark mode. Moment of truth. But I mean, already this is still much more interactive and way better experience than just sitting there and spinning and spinning and spinning and spinning, right? The goal is to just make this. Oh, here we go. Okay, so it is streaming content. It's just a little bit, it's like this content that's wrapped in a JSON object when we need to like, we actually need to like parse this out of its JSON format into like the, like right here. Content equals, so we need a case into this. In fact, I almost wonder if we can, rather than doing string message from LLM, let's look at our AI message chunk documentation in LangGraph. Is there a way just to get the information content? I think we just call content here. I think that's a string. Yeah, it's a string. It's a string or a list of a string. So even this right here, let's just try string. Okay. Okay, please change the, alright. Please add a game of Snake into this page. Here we go. I mean, this is way better. Look at this. Here's a high-level plan. So just unlocking this kind of, just calling this content and pulling out the information from this AI message chunk seems to be making it a lot better. It still doesn't seem to be streaming the... Oh, you know what? It looks like it's truncating this. Oh, here you go. Look at this. Oh, cool. So now it's actually like streaming this code information back. Yeah, way better. Way better experience. We just need yeah, now we just need to format this so it's a little bit nicer, and maybe the scroll bar stays stuck at the bottom. And then also it'd be nice if it like actually formatted it into this part of the app, which is node content. Oh, right, because right here it's actually truncating this a little bit. Data full content, node content, and then what's this? Design and plan. It's also truncating this. Data full content. So I'm going to tell it, don't truncate this node content and this data full content. Okay, where are we here? Chat. I'm going to say, please change this to not truncate the data full content node, and also please keep the scroll at the bottom when streaming back the HTML in that input box. In fact, let's get specific. Let's make sure that we're telling the LLM exactly what we want. So let's just take a look at this. Oh, here we go. Code. AI response content. Okay, this class equals code display. So we'll say pre. Okay, so we'll give it very specifically what we want. In the pre and code blocks. Okay, let's see what cursor can do for us. Okay, here's what it came up with. Okay, let's go ahead and hit apply. Okay, awesome. Go ahead and apply again. Seems pretty minimal. I didn't check the code too closely. Let's just, I didn't check the code too closely. Let's just see what it does. Oh, cool. Okay, it did snake. Okay, let's say, please turn this into a simple Pomodoro timer in night mode. Let's get rid of this little window here. Here we go. So this is so much better. Look at this. Processing route initial user message, write code, and then, oh, look at this. Way better, way better. Here's a high level plan. Okay. Processing design and plan. There it is. Okay, now it's starting to stream this back. The only problem now is if you do try to scroll, it like forces it to the bottom. The only other thing too is like, if this is a project that's for non-technical users to use it, then them seeing the code is gonna freak them out, right? But I think that at first, just as we're building this out, it's okay if it shows this kind of stuff. And maybe in the future we'll have like a mode that you can toggle. It's like if you're technical, you know, you can see the code as it's being generated. If not, you know, I think when people see code, like it freaks them out a little bit. Okay, so it did finish. And the other thing we need to do is we need to have it refresh the page when it finishes. Let's go ahead and refresh this. Okay, very cool. We also aren't saving the message history yet. That's the other thing. Is every time you refresh the page, there's no persistence on the message history. LangGraph has some cool tools that we can look into for doing that. But either way, you know, this is a little bit of a longer video, but the thing that we're just trying to do is we want real-time streaming, and this is one of the benefits of using LangGraph. We didn't have to like work with any of the async streaming from the large language model providers directly, which means we can easily swap out large language model clients because it's all encapsulated with LangGraph. So if we go to our base agent here, then we could come in and very simply change this chat OpenAI interface And as long as our invoke method is followed properly, then we get real-time streaming, and we don't have to, like, Claude, OpenAI, open source models, they might have different standards for how they stream things, but we just know if, as long as we follow, because we have LangGraph in place, as long as we just follow the LangGraph way of doing it, which is you evoke the stream with this .stream object and you give it a stream mode, then any model that LangGraph supports will already follow this format. So that's a huge, huge advantage. And also this wasn't too hard to kind of, like, not only are we streaming the LLM tokens back in real time, but we're streaming the real-time node information about where our agent is at in the thought process. And we're not just that, but we're seeing the intermediary steps of the large language model as it's thinking through each step. The only other thing I want to change, though, before we wrap this up, is just another interface thing. Rather than saying processing, I want to say thinking. Just like this. Just make it a little closer to the UX pattern, or the the user interface that OpenAI uses and other providers, where they say it's thinking. But based on that, we have a much more impressive demo now. It's a little more fun to watch. There's some other cool things we can do, such as, like, you could stream the HTML content into the iframe dynamically so that the user can watch the page being created in real time. Like, not just showing the code, but actually trying to format the HTML so that it actually shows on the page as it's building. We might do that in a future video. I think that what we have right now is good enough from a user experience point of view. It's a bigger step up. This project's being developed and built in real time. If you are watching this, I know this is a long video series. If you are watching this, let me know what you might want to see next, what kind of things you might want to prioritize next. I'm currently working on a roadmap that I'll publish publicly for everybody to kind of look at. One of the things I really want to do is I want to make this full stack. Right now it's just developing HTML pages, but I want to add a persistence layer that's using SQL, like a database SQLite kind of persistence layer. And I also want to add the ability for the agent to actually write Python files as well that maps the data layer and the front end layer. And I want to, like, do it in a way that makes this very reliable, but also very simple and elegant. And that's definitely a big thing on the roadmap. We also have some other things, like slowly introducing more tool calling. We also need to think about how we're going to deploy this thing, like, very easily and rapidly, which, there's a couple of options. We can put it into a Docker container, which makes it really easy to slip into a service like Railway or Fly, or even AWS. AWS has a lot of great services, and Google Cloud Runner has a lot of great things. We also want to add in some level of version control. So maybe, like, there's a node in our agent graph that can, like, automatically commit things to Git, kind of setting up checkpoints that way. We also need to add in persistence for the AI messaging so that it can, like, remember the messages that you've had previously. Maybe even we need to have a way to have different conversation threads, and maybe even have different apps. So it's not just one page.html, but maybe you can have multiple different projects going on at the same time. So these are the things that we're all thinking about, but we'll figure that out. And thank you for watching. Thank you for commenting. Thank you for liking. If you have actually watched this all the way through, I appreciate it. These videos might be better watched on 2 times speed or 1.5 times speed, just because there is a lot of coding that goes into it, and it's a pretty long video. It can get pretty boring pretty quick. So anyways, hope you can see the progress we're making. Hopefully this is modeling kind of the thought process that, if you're engineering an agent system from scratch, these are the types of things that we're reasoning about and thinking about. Streaming, nodes and edges, and thinking through the graph and being able to visualize the graph, using that, and being able to debug the graph, being able to have prompts saved in a place that's easy to pull down into your project and iterate quickly on, etc., etc. So anyways, thanks, and I'll see you in the next video.